Jim Jen, J-E-H-N is the last name.
And what's your official title with the company?
I am president of Jen Water Consultants.
Wonderful. Tell me a little bit how Jen Water Consultants got involved in this whole situation.
Well, we're the water consultant for the town of Sedalia, and we do water rights and water supply consulting for the town. The process for this particular well we got involved with because the well has been failing over time, losing production, and we were asked to provide some examples and opinions as to what to do with the well. So our opinion was that the well would need to be cleaned up because it is an older structure.
Is it common for wells to fail?
Some wells, it's more common than others. This well in particular is drilled into the alluvium, the sand and gravel material of Plum Creek in this area. And a lot of times those particular wells over time will become clogged. A lot of wells become clogged, and these type of wells become clogged more often typically than others.
From the sand and stuff?
Well, that's clogged from scale, and in this particular case is not only scale, which are chemical deposits out of the water supply itself, but also a bacteria has developed in the well, clogging the intake structure.
So you guys have determined it has failed. What are the steps to make it not fail?
In a sense, failure means it's lost production from the permitted and decreed production level of 125 gallon a minute. The latest test on it where it was down to 18 gallons per minute. So that means, in a sense, failure, but it's actually lost production in the sense that it's not really a producing well that's particularly good for the city to use. So the steps in this particular case were to pull the pump and motor out of the well, and when that process was done, it was determined that a lot of scale and iron bacteria were coating the intake of the pump and the drop pipe and wire and the rest of the materials coming out of the well and the motor.
So what do you do to clean that out?
Well, in that case, they're going to replace the pump and motor once we figure out what the production will be once we improve the production. The production is improved in a multiple step process. That process involves the first thing you do is brush the screen sections of the big wire brush. Once that's done, then all the material, the scale and bacteria is bailed out of it. Once the bailing is completed and the well is back to its original depth of about 65 to 67 feet, then the material is added to the well, so the chemicals are added to clean up the rest of the scale actually attack. So that chemical is added to the well. And then that chemical is what's called surged back into the screen and surrounding gravel pack and the surrounding aquifer area to make sure that the bacteria in that area are surrounding the well. And that chemical is left in the well for 24 to 36 hours. And once that time is up, that's pumped back out. After that's done, then a chlorination process begins. It's called superchlorination. It's a heavy chlorine liquid that's added to the well. And that's set in the well, and that's surged back in the surrounding areas of the well itself. That's left to set for 24 to 36 hours. Then that's pumped out. And that's the process that's going on today. That's pumped out. And the final step is a video, a down video of the well itself to make sure that it's clean. If there's still some areas that aren't clean, we'll repeat that process in those particular areas. So once it's clean, then a test pump is set in the well to determine what it will produce now under these rehabilitation conditions. And then based on the information we get from the pump test, the new pump and motor will be designed to bring it back up to a better production, hopefully closer to the permitted production of the well.
Okay, so I'm an ignorant city boy, and when you say well, I'm picturing this big canister underground, which I know isn't correct, but give me a defined well. What is it, and how big is this one?
Well, the well is drilled with a large hole, okay, let's say a 12-inch hole. Inside that hole, down to the bottom of the well, which in this case is, like you said, I think 67 feet deep in the sand gravel. And during that process, the drilling process has a bentonite-based drilling fluid to keep the well open. So the well is a 15 or 12-inch hole down in the ground, and that bentonite keeps the hole open. And inside that hole is set a casing and screen. The screen is a wire-wrapped material that has design slots in it to allow the water to come in. Once that's in place, then there's a sand, we call it gravel pack. It's a sandy type material that's added to that space between the screen and the original sand and gravel material, the natural material. That's added as a filter medium to keep the sand out of the well. So once the pump is placed in and it pulls water in through those screen openings, there's no sand brought into the well. Because sand is an enemy of pumps. It kind of chews them up. So we try to keep the sand out by properly designing the wells. So once that is completed, then there's a cement top above the sand pack to keep any unnatural material out of the well, to keep it from anything that drains off the surface that is at the very top of the well, the top 10 feet or something. And then there's a cap, of course, and the well has inside it, then when it's completed, it has a pump and motor unit. It has the electrical wire going down and the drop pipe coming up. So it's a submersible pump and motor. And on the top of the well is a cap. You don't even see the discharge. The discharge goes out through the ground through a unit called a pitless adapter. The discharge, a pipe, goes to the supply. So we're replacing the pump, the motor, the wire, and the drop pipe that were all contaminated and old. And so everything will be new inside the well once it's completed.
Wow. So you already kind of answered this, but I'm gonna retouch on it. What is the process you're doing today, and how long will that take?
Today is pumping out the super chlorinated solution so that the well is back to the natural water conditions. That'll take the rest of the day, I imagine, a few hours to the rest of the day from now. And then it'll sit and they'll do a video when that's scheduled. The video will be, I don't know when the video is scheduled for, today or tomorrow, but it'll be soon. Make sure the well's clean again, and then we'll get the test pump out here, and the contractor Lane will put the test pump in and do a 24-hour pump test on it so we can determine the parameters for the final design of a new pump and motor.
So do you physically, you were saying you have to remove that screen?
No, the screen stays in the hole.
Oh, okay.
The well is intact, it stays in place. That's what we're cleaning up, the screen and
gotcha.
anything behind it
Okay.
that occurred from a bacteria standpoint. We're trying to clean that up. So everything stays in place. We're just pulling the mechanical units out of the well, the pump and motor and wire and drop pipe.
Okay. So pretend I'm a resident of Larkspur. Once you're done here and everything meets your standards, how am I, a resident of Larkspur, going to benefit from this?
Well, the supply will be increased from the standpoint of this particular well. There's 3 wells for the town of Sedalia. There's 2 alluvial wells. This is number 2. There's a number 1 in another location, and then there's a deeper Arapaho aquifer well. That Arapaho aquifer well is more than 1,000 feet deep. Okay, that's into the Arapaho aquifer underlying, so it's 1,500 or so feet deep. These 2 alluvial wells are part of the supply. The first alluvial well only produces a few gallons per minute. It was never up to the production of this one. When this one was completed, it was 125 gallons a minute under test conditions. And then it dropped off, like we said, to 18 gallons per minute. So what will happen here is the Arapaho is probably the main supply for the town. They need 25 to 30 acre feet a year. An acre foot is 325,851 gallons. So they need 25 to 30 acre feet a year for their supply. All 3 wells combined supply that supply. The 2 alluvial wells are a lot cheaper to produce water from because they're shallower. You don't have to lift the water as high. The Arapaho aquifer well, the pumps have to lift that water 1,000 feet to the surface. It takes a lot more energy. If we can improve the production of this alluvial well, the energy cost will drop for the town, less costly water. So that's one of the reasons for doing it. It's certainly a very important reason to do it.
Yeah, that's great.